Okay, so we're now going to get into some of the actual divisibility rules. These are some nice tricks. Tests for divisibility for 2, 3, 4, 5, 6, 8, and 9. Now you might already know some of these. That's great. What I'm going to do, if you're following along on the slides, I'm going to be skipping some of these slides just because they get a little repetitive and it would be a really long video. I will show you, I will go in depth with the very first example so we can see how those properties from the previous video relate to what we're going to be doing here. I don't think it's necessary to go in depth into all of them. But if you are interested, they are on the PowerPoint slides. So let's go ahead and get started. We're going to start with divisibility by 2 or 5, right? We're going to kind of talk about these at the same time because they're similar in a lot of ways. So a number is divisible by 2 if and only if the number represented by the unit digit, right, the ones place, is divisible by 2. So as long as the last number ends in a 0, 2, 4, 6, or 8, it's divisible by 2. Doesn't matter how long the number is. If it ends in a 0, 2, 4, 6, or 8, then yes, it's divisible by 2. Similarly, a number is divisible by 5 if and only if the number in that unit digit, right, so the very last place value, is divisible by 5. So it really has to end with a 0 or a 5. So for these, all we're checking is the last digit on the right, the ones place, the units digit. That's all we have to do. So that's a fairly straightforward one. So you go ahead and try that with these. Okay, true or false on each of these, true or false. This one is probably fairly straightforward for many of you. It's probably something that you're familiar with, but if not, that's fine too. So number one, 2 is divisible or divides 13,776. All we have to do is look at this last digit. Because it's an even number, then yes, 2 does divide that number. For number 2, 5, does that divide 3,135? Well, all it has to do is end in a 0 or a 5. So yes, that is true. Number 3, 2 divides 2,461. It ends in a 1. That's not an even number. So that is going to be false. That's all we have to look at. Now, it's great, right? But I also think really understanding how this all works, we have to dive a little bit deeper and investigate the why, right? Why is this? Okay. You might have known these already, but I want to really investigate why. One way to investigate this is to look at a picture. Now, I could ask you to get your base 10 blocks out here to see, but I think we can just look at the visual. If you want to get them out, it could be helpful too. So what this demonstrates here, this picture, is investigating whether 2 it divides the number 2,573, right? That's the question, right? 2,573. Does 2 divide that? That's kind of what we're looking at. And so we know we look at this last digit, okay? So what you're going to see here are the different the long flat, the long, and the units piece of these manipulatives. And you can see there are little dotted lines, right? So what we're doing is we're taking each of the long flats and we're evenly cutting it into 2 pieces, evenly cutting it into 2 pieces, and then we go to each one of these. Same thing, 2 pieces, 2 pieces, 2 pieces, 2 pieces. We just keep doing it, right? With the longs, we cut them horizontally, 2 pieces, 2 pieces. And then what we end up with here are 3 units. So it all comes down to the units, right? And what we see is, oh, well, there's something I could cut that in half but I can't cut that in half, right? So there ends up being this one left over that I can't cut into two pieces. So it's fairly easy to see why that is not divisible divisible by 5. And we could do a very similar drawing to investigate whether 5 divides into 2,573, right? We would end up cutting these things into 5 groups of 5, and you would see the same thing. You would end up with this group of 3 at the end, which was not divisible by 5. What I'm really a little more interested in here right now is some of the numerical investigation. And here's where those properties we talked about in the previous video are going to come in handy. And so what we're going to do is we're going to look at the expanded form. I think this is fairly interesting here. We're going to look at the expanded form of 2,573. And we can take that number and we can write it as 2 times. Now, its place value is 1,000, right? And I'm just going to condense it and write 1,000 as 10 to the third. Plus, then we look at the next digit, the 5. 5 times 100, because it's in the hundreds place, but we'll just condense it for the sake of space, 10 to the second. Plus, do it again, 7's in the tens place, 7 times 10 to the second. And then we have our units place, plus 3 times 1. And so what we're going to do is we're going to use those some of those properties from before. In fact, what I'm going to do is I'm going to go back and grab those properties from the previous video. You may recognize some of this stuff. I'm going to grab them. I'm going to take this and I'm going to copy it, and we're going to paste it so we can see it. I'm going to just put those. I'm going to shrink them just a little bit so we can refer to them as we go through these. And so the first one I'm going to investigate is property number 3. If one number divides another number, then it will divide the product of that number with any other whole number. And so we're going to use that property right now. It has to do with the place value. 2 divides 10 to the third. We know 2 divides 1,000. Okay, 2 divides 1,000. It's ends in a 0. So we know it divides 1,000. So because of that, 2 also must divide the entire thing. 2 times, let me erase that, 2 times 10 to the third, right? 2 has to divide that entire thing, no matter what whole number we put here, right? It doesn't matter if this is a 1, a 2, a 3, or 4, or 5, or a 6. It doesn't matter, right? Any number can be in that first place value because of property number 3. As long as 2 divides 1,000, then 2 is going to divide 2 times 1,000. Same thing here. We know that 2 divides 100, which also means that 2 must divide 5 times 100. It's going to divide the entire thing. And I'll even put parentheses around that, just so we know that we are looking at that entire expression. The same thing happens here. And I just realized that I made a mistake way back here. I should not have put a exponent of 2 on that, 10. And we get down here. We know 2 divides 10, right? 2 divides 10. So 2 must also divide 7 times 10, right? It doesn't matter what number we put there in front, it's going to divide its product. So we're using property 3 for all of these, right? Property 3 says all of this stuff is divisible by 3, okay? Or divisible by 2. So then what we're doing is we are going to look at this, okay? Well, we know that 2 does not divide 1. It doesn't divide 1, something in that ones place. Therefore, we know that 2 does not divide 3 times 1, okay? And that's by property number 2, or not by property number 2. It's really saying that property number, right? Property number 3 is not true there. We know that 2 does not divide 3, but then we're going to investigate number 2, right? This entire big chunk of the problem, right? This entire first part right here is all divisible by 2, but this part's not. And so divisibility property number 2 says if a number divides one of 2 numbers, but not the other, then it will not divide their sum. So even though 2 divides all of this stuff, right, up here, but it doesn't divide that thing, then it's not going to divide the entire sum, 2,573. So what we do, the way we do that is, again, we're looking at like each of those individual place values. Can we prove mathematically that 2 divides that first number, the second number, the third number? Okay, that's holding true for everything from property 1. But then because it does not divide that last number, property 2 says we know it doesn't divide the whole thing. That might be one of those things that whenever we start to apply those properties and try to use them to define and prove things, it can be a little bit challenging, right? But divisibility by 5 is actually very similar, right? You could do that exact same thing with the number 5. So let's move on, and we're going to talk about divisibility by 3 or 9, because these are also very similar. Maybe this is one you've heard of, maybe not. I think this is one super fun. If a number is divisible by 3, or a number is divisible by 3, if and only if the sum of its digits is divisible by 3. And the same thing for 9. A number is divisible by 9 if and only if the sum of its digits is divisible by 9. And so here's what those look like. If I give you a number like 204, and I ask you, is 204 divisible by 3? The way you can figure that out is take 2 plus 0 plus 4, and you get 6. And then you ask, is that number divisible by 3? And because 3 divides 6, because 3 divides 6, then 3 must divide the original number 204. Okay, so as long as 3 divides the sum, then 3 is going to divide the original number. Okay, and the same thing works for 9. So go ahead and pause and try these. Are these statements true or false? So let's look at the first one. So number 1, it's asking, does 3 divide 2,847? Well, 2 plus 8 plus 4 plus 7 is equal to 10 plus 11 is 21. And 21 is divisible by 3. And even if you're not sure the first time, you can even do it again. 2 plus 1 is equal to 3. 3 divides 3. So yes, that is a true statement. True, 3 does divide 2,847. Let's look at number 2. So we're going to take 1 plus 4 plus 7 plus 3 plus 8 plus 9. And so this is going to be 5, 15, 23, 32. Does 9 divide 32? No, it does not. So that is a false statement. Last one. 2 plus 3 plus 0 plus 4 plus 1 plus 5, 5, 10, 15. Does 3 divide 15? Yes, it does. So that is a true statement. Okay, so that's how 3s and 9s work. That's a nice one. That's a really nice trick. Now, we could do a lot of the investigation of these, kind of like we did before. I'm not going to go too far into it, but I do want to, because I think this is a really clever proof. I do want to talk about the divisibility by 3. And I'm just going to paste in here the explanation, and then I'm going to paste, copy and paste a little diagram to go with it. And I'm going to put them side by side. Actually going to make you a little smaller. And we're going to investigate this because I think this is a really, really, really clever proof. So follow me here. So it says to prove why this works, consider the base 10 representation for the number 2,847. That's what you see here, 2,847. And then what you have to do is consider from each of these original pictures, right? Each whole picture. That means this one and this one and this one and this one, like all of the individual pieces. Imagine what happens if you take away 1 unit. 1 unit from this little bottom corner, right? If we take that out, and we take that out, and we take all of these little 1 units out, right? We take them all out, also from the longs here. Okay, that's kind of the first step of the thinking. What are we left with? We started with 1,000, right? If we take 1 from 1,000, well, this now has 999, and so does this one. And don't we know that 999 is divisible by 3, right? That is divisible by 3. So as long as we take 1 away, then that's divisible by 3, and so is that. Well, what about this one? This had 100. If we take 1 away, now there's 99. Oh, hey, that's also divisible by 3, right? So that's divisible by 3. So is that, and that, and that. All of these are divisible by 3. Same thing here. We started with 10. We took 1 away. Now there's 9. So each one of these is divisible by 3. So now what we're left to check then is all of those individual unit pieces that are left over, right? Well, how many unit pieces came from these 2 groups of 1,000? 2. How many unit pieces came from these groups of 100? 4. No, 8, sorry, not 4, 8. How many unit pieces came from the groups of 10? 4 of them. And how many unit pieces were there originally to start? 7. So what we're really checking now is if we're adding all of these unit pieces up, 2 plus 8, right? 2 plus 8 plus 4 plus 7, it's just an individual collection of single unit pieces, which would be 10, 14, 21. There would be 21 individual unit pieces left, and 21 is divisible by 3, right? 3 goes into 21. And notice, right? Look at the numbers we ended up adding. All of those individual leftover single unit pieces, 2 plus 8 plus 4 plus 7, those were the original numbers that we started with, 2, 8, 4, and 7. So we're taking away 999 and 99 and 9 from all of those place values here, 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 and here. And these are the numbers that are left. Just those individual units. I think that's a really clever way to show that. And so the same idea works with 9, right? The exact same idea that we did here works with 9 because 9 also divides evenly into 999, 99, 9. So we can do that same idea with the number 9. I just think it's really, really clever proof for divisibilities by 3 and 9. Now we could also prove both of those using those properties. And again, like I said before, those are in the slides if you're interested in seeing those. I'm not going to address those here though. Let's move on to divisibility by 6. So divisibility by 6 is this. A number is divisible by 6 if and only if the number is divisible by both 2 and 3. So if a number is divisible by both 2 and 3, then it's also divisible by 6. So let's try these three. So I'm going to give you 3 numbers and go ahead and see if you can determine, are these numbers divisible by 6? Go ahead and pause and try those. So in order to be divisible by 6, then it has to be divisible by both 2 and 3. There's that word and. They both have to work, not just one of them, both of them. So for number 1, did you notice we can immediately rule it out? The final digit, the digit in the units place, the ones place, is odd, right? That's an odd number. In order for it to be divisible by 2, it has to be even. So this one, no. We would say 6 does not divide 561,781. What about this one? What about this? Well, it ends in a 2, so it's divisible by 2, but now we have to check the sum of the digits. 2 plus 1 is 3, plus 4 is 7, plus 7 is 14, plus 2 is 16. 3 does not divide 16, which means 3 does not divide the whole big number, which means 6 does not divide it either, right? So it is not divisible by 6. It worked for 2, but not for 3. So what about this one? It ends in a 4. It's even. That's good. So if we add all the digits, 1 plus 2 plus 3 is 6, plus 9 is 15, plus 5 is 20, plus 3 plus 4 is 27. 3 does divide 27, and it's an even number. Since both of those are true, we have one that works. 6 does divide 123,000, or 123,090,534. So that one, it works. That one, it works. And lastly, we have divisibility by 4 and 8. 4 and 8. So here are our divisibility tests for 4 and 8. Now, being able to do these, I think, is it's a little more challenging because it requires you knowing some higher multiples of 4 and 8 to test these. But what you'll see here is a number is divisible by 4 if and only if the number represented by its last 2 digits is divisible by 4. So if you have like a 6-digit number, big number, as long as 4 divides evenly into those 2 digits right there, then the whole thing is divisible by 4. The same is true for 8, except it's the last 3 digits, right? So if you had, again, a 6-digit number, 1, 2, 3, 4, 5, 6, whatever those last 3 digits are, 8 would have to divide into those 3. It doesn't matter what comes before, as long as those last 3 digits are divisible by 8. So let's go ahead and have you try some of these. Okay, so what did you come up with? For number 1, all you have to look at is the 32. We look at those last 2 digits. 4 divides 32. So this is a true statement. 4 does divide 65,932 because 4 divides 32. What about number 2? Look at the last 2 digits. Does 4 divide 14? No, it does not. So that means this is a false statement. 4 does not divide 476,025,314. Number 8, or number 3, now we're dividing by 8. Does 8 divide this number? So here we have to look at this entire 3-digit number. This might be a little bit trickier for you. Here's where I use a little bit of mental math, and I think it was property. It was one of the earlier properties. I think property number 1. I ask myself, not just 4, does 8 divide? And then I take 132 and I break it up into a couple numbers. One that I know 8 is divisible by, and then some other number, right? What's left after I take 80 away? 52. So remember, 8 would divide evenly into 132 if it divides evenly into both of those numbers. Well, we know 8 divides 80, 8 times 10, but 8 does not divide 52. So that's a nice way mentally to do a check for 8. So since 8 does not divide 132, this is a false statement. 8 does not divide 75,132. Let's look at this last one. So does 8 divide this? We only have to look at those last 3 numbers. I'm going to do that same idea. I notice 816 is equal to 800 plus 16. Well, I know 8 divides 800, and I know 8 divides 16, so that means 8 must divide 816. Therefore, 8 divides the entire number. That is a true statement. That is a true statement. And the reason that works, one last little bit here. If we think back to the very first explanation I gave, which I know is a bit challenging to understand at the very beginning. We did this for the number 2. I'm going to just copy and paste the whole explanation here. If you think about the number, this big number right here, right? If we look at 65,932, and we're trying to determine if 4 divides that number. One way to examine it, right? And maybe I'll explain it a little bit differently here. If we just look at these the first part of the number, right? Remember the test? The test for 4 says, as long as we're good with those numbers, then the whole thing works. The reason that really is because if we take those numbers off, 65,900, that is divisible by 4. And the reason we know that is because the number 100. 4 goes into 100 25 times. 4 divides evenly into 100. And this number is just a big multiple of 100, right? That is just a big multiple of 100. So that means 4 has to divide into that entire thing, okay? What we're looking at is the rest of the stuff, right? All we care about is that. We know that 4 goes into this part of the number, but does it also divide evenly into 40, 42? Okay, so that's kind of the same thinking we used back when we were checking out 2, but just a slightly shorter description. So there you go. There are your divisibility tests for 2, 3, 4, 5, 6, 8, and 9.